Hi everyone, this is 8th grade Elevate. Today we are working on solving multi-step word problems with fractions and decimals. So students are going to be engaging in all four operations today using fractions and decimals. So we are not going to pay attention to this first part, which is normally our introduction, only because this example focuses on only multiplication of fractions. So what we're going to do for this lesson is we're going to pick and choose some question types that are different to model so that when we gradually release students to work with partners, they're able to apply the skills that you have modeled. And so because today is on multi-step word problems, we also want to mention to students that this means they will need to do more than one step before getting to their final answer. And so with that in mind, I think launching students into a 3-minute turn and talk around how they can tackle this question is going to be ideal. It's actually the perfect type of question to let students know, oh, okay, this is what it means when we say we need to do more than one step, right? Because this question says Janine tried to solve the problem in one step. She multiplied 16 times 1, 8 times 5 sevenths. She was confused that her answer was a fraction. What would you tell Janine about her work? And so you might even want to ask, if we are working on multi-step word problems today, where do we see evidence of multi-step word problems in this specific question? Students will say, well, we are working with the word problem. Okay, then where do we see evidence of having to use multiple steps? And here students will say, well, we've practiced how to multiply a fraction by a whole number. We did that yesterday. But now we have another fraction that we also need to multiply. So we probably should do this first and then do this step, right? So there's more than one step. So from there, we're going to take you into a few different models. Most of the questions that students will be working on today are around fractions. So most of your models will also be around fractions, right? So this question says, while walking to school, Patrice saw that 1/12 of the cars that passed had one person in them, and 1/8 had two people. If Patrice was passed by 24 cars in all, how many have 3 or more people in them? So the first question that you might want to ask students is, how would you restate what's going on in this problem in your own words? So students might say, you might even ask them to restate it without even using the specific numbers. So students might say, well, there are 24 cars in all. Some of them passed by Patrice. They had one person in them. Another couple passed by Patrice. They had two people in them. What we need to figure out is how many cars passed us or passed Patrice that have 3 or more people in them, right? That's the bulk of what we're doing today. Then another question that you might want to ask students is, what math operation buzzwords do I see in this problem? This question is going to be very, very important because students need to be able to identify which operations they're going to need to do for this particular question, right? In math, we know of to indicate that there's some multiplication going on. We also know that in all tells us we're going to have to multiply. This is a great question as well because it lets us see that there are multiple steps in this question. So a student should not say that they're done if they have not done some semblance of multiplication and addition, right? And so the question takes you through a step-by-step of what students should do first. For instance, it tells you to write an expression to represent the fraction of the cars that had 1 or 2 people, right? This was a fraction that had one person, and this was the fraction that had 2 people. So adding these fractions together, You might want to ask, can I add these two fractions together? Students should automatically say no. Why? Because they do not have the same denominator, and we cannot add fractions if they do not have the same denominator. So that means that we have to create equivalent fractions, right? 1/12 ends up being 2/24, and then 1/8 ends up being 3/24. We get a total of both of these fractions now have a denominator of 24, which means that we did great math. Now we can go ahead and add them together. Keeping our denominators the same, we know that 2 plus 3 is 5. So 5/24 represents the cars with 1 or 2 people in them, right? And if we know that there's a total of 24 cars and 5 cars had 1 to 2 people in them, then that means that 24 minus 5 is 19. 19 cars had 3 or more people in them, okay? Because that's the question that the word problem was asking us. So as you can see, many different steps in this question. We had to add, then we had to find equivalent fractions before we were actually able to add. And then from there, we had to do some subtraction to get our final answer of 19. So from there, you will launch students into 10 minutes of work time. They will work on questions 1 through 4, and then 5 will be their exit ticket question. The beauty of this lesson is that it breaks up the steps for students. So just like this example here, it doesn't explicitly tell them step 1, do X, Y, Z. However, it lets them know what they're looking for, right? So find how many pancakes Lyle made. From there, you need to find how many pancakes each person took. Then find how many pancakes in all Randy and Matt both took, and then how many pancakes are left over, right? So all these questions that the students are going to work on for today, they are given some at-bats on how to tackle those questions.